The sixth important chemical property is about dehydration. When glycerol is heated with potassium bisulfate or concentrated sulfuric acid or even phosphorus pentoxide, dehydration takes place. Glycerol, an addition of KHSO4, that is potassium bisulfate, it forms an unstable intermediate. So therefore this double bond character shifts here and this hydrogen leaves. Thus on addition of hydrogen iodide, this double bond character leaves and iodine adds up to the center carbon here. 2-beta elimination reaction takes place to give acrolein or acrylic aldehyde. The seventh chemical property is about the action with oxalic acid. Depending upon the temperature, glycerol is converted to allyl alcohol or formic acid. At 383 Kelvin, glycerol monoformate is formed, where glycerol is first converted to allyl alcohol as shown here. This reaction takes place at a temperature of 383 Kelvin. Further on, decarboxylation takes place, that is, this double single bond character has to remove this hydrogen bond. Thus, glycerol monoformate is formed. This reaction involves the formation of monooxalate as shown here. The product obtained on hydrolysis gives formic acid. That is, as we have seen in the previous one, glycerol oxalic acid is formed. On addition of water to this reactant, we obtain glycerol and also formic acid. In this reaction, the glycerol acts as a catalyst. At 533 Kelvin, glyceryl dioxalate is formed, which eliminates two molecules of carbon dioxide, forming allyl alcohol. If we can see here, glyceryl reacts with this compound, and further on, if you can see, this oxygen and this CO goes out as CO2, therefore forming an unstable compound. Therefore, the other CO2 also leaves the compound, and thus we would obtain a double bond between the C carbon at the first and the center. And also we would be obtaining 2 moles of carbon dioxide because of the leaving groups here as a byproduct. Action with oxalic acid. Glycerol acts as a catalyst as we have seen in the previous reactions. Oxidation. Theoretically, glycerol can give rise to a large variety of oxidation products. The actual product obtained depends upon the nature of the oxidizing agent and the concentrations. Theoretically, glycerol can give rise to a large variety of oxidation products. The actual product obtained depends upon the nature of the oxidizing agent and the concentration. With dilute nitric acid and glyceric acid is formed. With concentrated nitric acid, glyceric acid and tartaric acid are formed. Bismuth nitrate converts glycerol to mesoxylic acid. Milder oxidizing agents like bromine water or Fenton's reagent or sodium hypobromite oxidizes glycerol to glycerose, which is a mixture of glyceraldehyde and dihydroxyacetone. Strong oxidizing agents like warm acidified permanganate convert glycerol to oxalic acid and carbon dioxide. As we can see in this following reaction, this primary alcohol on oxidation with oxygen gives an aldehyde. On further oxidation, we would obtain an carboxylic acid along with carbon dioxide as side product. But for a secondary alcohol, we would obtain a ketone and oxalic acid as a result. And tertiary alcohols cannot undergo these reactions because we know that it doesn't contain any acidic hydrogen.